Forensic Science Lecture 16-4, Methods of Detecting Fingerprints. The Automated Fingerprint Identification System, or what we refer to as AFIS, is the database of fingerprints. In 1999, the FBI initiated full operations of what we now call the Integrated Automated Fingerprinting Identification System, or IAFIS. It's the largest in the U.S., and it links the state AFIS computers to the FBI databases. Until the emergence of fingerprint computer technology, the manual approach to fingerprinting was taken with ink and then a fingerprint card. And this was the only visible method of maintaining fingerprint collections. Different AFIS databases range in size from the FBI's, the largest in the U.S., to independent systems which are operated by cities, countries, and other local governments. However, because of the differences in the software configuration, only local databases can see their own AFIS system, so they can't link between states. So this is a barrier that needs to be confronted. But the way that AFIS works is it's technology with the ability to scan and digitally encode fingerprints. It's a very high-speed computer process, so it speeds up the process of doing a point-by-point comparison of everything on file. It converts the image of fingerprints into digital minutiae, showing the points of termination, which are the ridge endings, the bifurcations, which are where the ridges branch into two ridges, relative position and orientation. An algorithm is then used to determine the degree of correlation between the location and the relationship to the minutiae on both the search and the file print. And then this has the ability to make thousands of comparisons per second. And then it produces a list of file prints to be examined by an expert. So it's not 100% matching. There has to be an expert that is then going to manually examine it. Today, the 10 print card really have been replaced by digital capture devices. These are known as LiveScan, and this allows agencies to enter into the print and search the database within minutes. And usually for most jobs that you go to, you have to have a fingerprint done, and it'll be done through this LiveScan, especially if you're ever going to work with children. One thing that AFIS has done is it changed how investigators operate. Okay, it allows for less time in developing the suspect list and more time for investigating these suspects. There is times in which a latent print isn't going to get a hit on AFIS, and this can be due to poor quality of the print on file or poor quality of the print that they're searching. And so investigators must still print suspects and manually search prints at times. Software incompatibility means that state systems can't communicate with the FBI integrated AFIS. And so local and state often do not share information with each other. And this is where we come into problems where we have serial killers, for instance, that go from one state to another. It's the reason why it takes so much time to actually catch them. But there are three types of prints that can be found at any crime scene. A visual print, which is made by fingers touching a surface after they've come in contact with a colored material. Could be anything from blood to paint to grease to ink. Plastic prints, which are made when the ridges are left impressions into a soft material like putty, wax, soap, even dust can be considered a plastic print. And then latent or invisible prints. And these are made by the transfer of perspiration or the oils that are coming from the sweat glands to the surface. of the scan and then transferred to the surface or the object that is being touched. So locating the visual and plastic prints is pretty straightforward. Usually presents little problems being able that you can actually see this distinct fingerprint. Latent prints or invisible prints require the use of techniques in order to make those prints visible. And the technique that's used is going to be determined by the surface that is being examined. So any sort of prints that are deposited on a hard or non-porous surface are preferably developed by the application of powder. So a hard surface would include things like glass, mirrors, tiles, painted wood, anything that's non-absorbent. Prints that are on a porous surface generally require a treatment with a chemical. So a porous surface would be things like paper, cardboard, clothing, sheets, things like that. That would all be considered porous, anything that's absorbent. And so that needs to be treated with a chemical in order to bring out that print. There have been recent developments that can locate latent prints without powders or chemicals. It's a device known as RUVIS, Reflected Ultraviolet Imaging System, and basically it uses ultraviolet light that reflects back into a viewer, and it can differentiate between the print and the background. So developing prints with fingerprint powders, they're applied either by a brush or what's known as a magnetic wand, depending on the powder. The powder's gonna adhere to the perspiration and the body oils of the print, and then the powder is gonna come in different varieties of colors. And what color they use will be based on what the color of the surface is and what's going to contrast it best. There are some powders that are magnetic sensitive powders, and these can be applied with a magnetic brush, or also known as a magna brush. And so there's no bristles on those, which means that it's not touching the print itself, which has a less chance of being destroyed or damaged in any way. And then there's also powders that are fluorescent, so that when they apply it and then they view it under a UV light, that it will glow to show that print. Another developing method is called iodine fuming, and this involves heating iodine crystals that cause vapors. Iodine crystals have the ability to go from their solid phase directly into their gas phase without passing through a liquid phase. It's known as sublimation or sublimation, and this is what makes it so good for developing the print. But the suspect material is placed into an enclosed cabinet with the crystals. It's heated. The vapors then combine with the latent print and make them visible. The problem with this is it's not permanent. They fade fairly quickly, and so investigators need to take a photograph of the print immediately in order to create that permanent record. There's also a process or a chemical that's known as ninhydin, and this reacts chemically with the amino acids in the perspiration, and it produces a purple-blue color. Prints can appear within 1 to 2 hours after being applied, but weaker prints can take anywhere from 24 to 48 hours. Again, this is going to be the method of choice for examiners when dealing with the porous materials, because it's extremely sensitive and it's easy to apply. There's also a developing process that uses what's known as physical developers, and this is a silver nitrate based reagent and that's used to develop the print. And this is used when all other chemical methods are ineffective. It does, though, wash away any traces of proteins that may be present. So all other methods of analyzing that print need to be done prior to this physical development or developer method, because after that, the print's destroyed. There's nothing else that they can do with it. There is a developing method for non-porous surfaces that is known as superglue fuming, which we will actually do in the next lab. But fumes are accomplished using a fuming chamber or a handheld wand that heats up a small cartridge containing the superglue. The fumes of the glue then adhere to the print and produce a white latent print. So remember, this is non-porous substances, so metals, electrical tape, leather, plastic bags can all use the superglue fuming. But the fuming chamber basically is an enclosed space that includes a cotton ball that's been treated with sodium hydroxide and superglue. And then when placed into this enclosed space, it heats up and causes fumes. So the fumes then, like I said, adhere to the print and cause it to be a whitish in color. It can take up to 6 hours to develop a print, depending on the latent print itself. But it's fairly successful in its process. Other techniques for visualization are exposure to laser lights. So perspirations actually contain a variety of components that fluoresce when illuminated by laser lights. And because of this led to the next advancement of fingerprint development, which adds chemicals to the prints to enhance this fluorescence ability when exposed to different alternative lights, like a halogen or a xenon arc light. Or even LEDs. And so these are just as effective as the laser lights, but it is the next technique in not having to use all of the powders and so on, a little less messy. This ends lecture 16-4. There's a quiz next class.